In this video, we are graphing systems of equations. We're going to do some more examples, and we're going to use Desmos to graph these equations. So make sure that you have the Desmos NC test version pulled up. The regular Desmos that you type in may not be exactly what we need. This is the version that you will have on your final exam. So you can use these letters. You have y equals 2x plus 3. You can also use the keyboard that's on your computer. Our second equation, I'm just typing in a new box, so I just click in the number 2 box below that one, and I'm going to type y minus 2x equals 3. So notice that you can actually click on those squiggle lines, those buttons beside each equation, and it will turn the line on or off on the graph. So notice when I have the red one graphed, then when I click the blue one to turn it on, it's the exact same line. So I'm going to zoom in just so you can see that it's not two separate lines that are just really close. They are actually the same line. Whoops. Okay. So we can see that since these are the exact same line, they have an infinite number of points in common. Right? So any point on this line is on both of those lines because they are the same line. So you can see how I'm just dragging these points. That's an infinite number of points. So there are infinitely many solutions. So another way of writing that, just in a shorthand as an abbreviation, is IMS. Right, number 2. Again, we just want to find the solution to this equation. So notice I closed out the other 2 equations because we're using a new set of equations. And I'm going to click the little house on the right-hand side of the Desmos screen. That little house takes you back to a standard-sized window zoomed in. So now we're typing in 3x plus 4y equals 12. So you'll notice that these are both in standard form, and that's okay because Desmos will still graph them in standard form. We don't have to have just y equals equations for Desmos. All right, now when I graph these at first, they don't look like they cross, so we need to make sure that we zoom out to see the intersection. Okay, so I'm going to zoom out of Desmos. So just I'm going to click and drag. You can also use the minus button on the side to zoom out. Now we can see that there is an intersection, and I'm going to click on that point, and it will show us the point of intersection. That intersection is at the point 36, negative 24. So that is our solution, is the point 36, negative 24. I'm going to close out these 2 equations because we don't need those any longer. And I'm going to click the home button so that I go back to a standard zoom. All right, I'm going to click in box 1 and we're going to type y equals 4x plus 2. And in a new box, y equals 4x minus 7. Okay, these 2 lines, they don't appear to intersect, but again, we do want to zoom out so that we can see for sure that they never cross. Okay, so they are never going to cross one another. So that means that they do not have any solutions. Right, number 4. Close out the equations that we have. Go back to a standard zoom. So click that little house. And in the first box, we have 3y equals 6x minus 15. And in the second box, we have y equals, now this time we have an x squared. So I'm just going to make a note here in Desmos to type an x squared, you're going to click the button a to the power b. Or you can click the button a squared. All right, so we have y equals, we're going to type x, and then we have the squared, and then we're going to type plus 4. So the blue line and the green quadratic never ever cross over one another. So there is no solution. All right, number 5 is another quadratic. I'm going to zoom in, or you could click the little plus button. We can see that there is a line. I'm going to change the color of that so that it's not black. Let's make it red. Okay, so we can click on those intersection points and see what those intersections are. All right, so this red line goes through something kind of like that, and we want to look for those intersection points. Okay, so we got a point here, and we got a point here. All right, those 2 points are negative 0.5, negative 4.5. Okay, so that's 1 point. And the other point is 1, negative 3. So this has 2 solutions. Number 6. Which of the following is a solution to the system? So I'm going to cross out what we have here. All right, so now notice I can only see one of those lines. That's because I didn't click the home button the last time. So I'm going to click that home button, and it gives me a standard window to look at. Now, originally, it doesn't look like there are any intersections. So we are going to need to zoom out to see the intersections. So now what we're looking for is which of these 4 points is that intersection point. All right, so when we graph these 2 equations in Desmos, we see first your screen will probably be zoomed into the standard version, so you'll need to zoom out to see the point of intersection. And this question's really only asking for that intersection point, which is negative 80, negative 42. But you can also check this by hand algebraically. To do that, you're just going to take the x value and plug it into each x in the equations, and take the y value and plug it in for each y value in the equations. And we want to make sure that what we get is that this side of the equation equals 30. So basically we want to make sure that this stuff is equal to 30 when we plug in that x and y. Same thing over here. We're going to plug in the x and y, and we want to get that 8 equals 8. So first we'll take negative 80 and negative 42 and plug them in for x and y in the first equation. So we'll type that into Desmos just to see what it's equal to. And we do get that that is equal to 30. Then we'll do the same thing in the second equation. And we do get that that is equal to 8. So since we got that the x and y values plugged in give us 2 true equations, that is how this is the solution to the system. In number 7, we have a quadratic, x squared minus 3x, and we have y equals negative 3x plus 1. Right, so we're going to find our solution, so we're looking for the intersections. Now, we need to zoom in to see the intersections on this one. Okay, so there are 2 solutions because this green line, that linear function, crosses the quadratic 2 times. It crosses at the point negative 1, 4, and at the point 1, negative 2. All right, and number 8. Okay, this one's multiple choice. It says, which system has infinitely many solutions, and how do you know? So infinitely many solutions, that means what? That there are an infinite number of intersections. So infinitely many solutions means that they are the same line. Okay, So we're going to know that one of these systems has infinitely many solutions if the graphs are the exact same line. So I'm going to pull up in Desmos that keyboard and type in each system separately. So y equals negative x plus 5 and x plus 2y equals 4. Okay, that has an intersection. So this graph looks like two lines. Okay, this graph looks something like this. So this one has one solution because they cross one another. So it's not A. Let's try B. So I'm going to close out the two equations we have. We don't need those anymore. Go back to the home, zoom, and then we type 3x plus 4y equals 24. In a new box, type x plus y equals 10. Okay, now at first it doesn't look like these cross, but we want to zoom out. And again, these do cross. So this also has one solution. We're looking for infinitely many solutions. Okay, let's try the next system. So x plus y equals 7 and 2x plus 2y equals 14. Okay, so notice what happened just then. The green line that I had graphed was covered up by the purple line. So what I'm going to do is zoom in really far to make sure that they're not two separate lines that are just really close. We want to make sure that they are two lines that are the exact same. So when I turn off the purple line, it is directly on top of the green line. Okay, so since these two are the same line, they have infinitely many solutions. So our answer is going to have to be C, but let's check on D and see what's going on there. Okay, notice that D is a quadratic, and if we have a quadratic and a straight line, they're either going to cross once, they're either just touch one time, they're either going to cross potentially twice, or they're not going to cross at all. But they can never be the exact same line because one is a U shape and one is a straight line, and those can't overlap one another every single time. All right, so let's just see what this one looks like. All right, we have y equals x squared minus 4, and y equals 2x minus 4. All right, again, I'm going to click the home button, and now I can see that this quadratic and that line do cross each other twice. So this one has two solutions. Okay. And numbers 9 and 10. All right, 9 says what value of y makes the system of equations true? So what value of y makes the system of equations true? So this is asking what is the y value of the solution. The y value of the solution point is just, if you look at your solution, xy, we're just looking for the y value. All right, so we're not looking for a y-intercept. So notice that you see some little gray dots come up when you graph those. We're not looking for a y-intercept. We're not looking for where the lines cross the y-axis. We're looking for where do these lines cross one another and what is that y value. Okay. And they cross at the point 2, 1. So this is the solution. If this is an xy point, we are looking for the y value, which is 1. So the y value 1 is what makes these two statements true. And number 10 is very similar, but it says what is the x value that makes the system of equations true. So it's really asking what is the y value of this, or the x value of the solution point. Okay, so again, if we have the point that is the solution, xy, we're looking for the x value this time. The point of intersection is 5, -2, and we are looking for the x value. It says what value of x, so we're looking for 5. Okay, so this is pretty much all the different types of questions that you would see about systems of equations and how many solutions and what types of solutions there are.